Okay, Boolean variables and conditional statements. So, conditional statements are used to branch an application's execution flow, and they'll generally involve some kind of true or false test, some kind of this, not this kind of operation. For example, I feel like we did this, but we didn't actually do this. I just did this in my 313 class where I cover the same stuff in JavaScript, more or less. So imagine if you have a login sequence, right? So we have something like display login screen. Let's stretch that out. We can stretch it out that way. Okay. Display login screen, user inputs, ID and password. Okay. And then we do a check. Okay. So these boxes, these are actions in our program. This is a very low quality flow chart, but it is a flow chart nonetheless. Okay. Display the login screen, user inputs ID and password. And then we have a couple of checks. Not chucks, we have checks. Check 1. Does ID exist in database? Okay, and these will lead to different outcomes. So here's a test. We're going to just indicate that by a diamond. And the reason why I do a diamond is we have these natural branch off points from it. Okay. Does the ID exist in the database? I didn't want that, I want the line. If so, right, of course, then we're going to go check the password. If not, then we're going to go back up here. So I'm going to do a no branch, and I'm going to do a yes branch. Okay, so if no, we're going to go up here. We're going to display login fail, ID not found. Okay, so we'll do some message that does that. And then we'll go back up here and wait for the user to input the ID and password again, right? So if the ID isn't found, what are you going to do? Right, you go back and you display that thing again. Now, if it's the other thing, right, we'll just round it up this way. The next one is going to be password match ID. Okay, guess I'll make that check 2. So if the password matches the ID, well, then that's great, right? We let people into the system. So I'm going to do yes. Let's bring that down here. And like I said, that's great. You're in the system right here. Good to go. Boom. Right? Because that's how that works if the stuff matches. And if it doesn't match, well then, we have another thing to do, right? So if it doesn't match, no. Then we might do something like, again, some kind of login fail. Maybe we have another branch here, depending. We say increment login fails for that ID, possibly block the account, right? And that whole thing, again, would lead to another yes or no type case. I'm trying to grab this so I can move it up a little bit. There we go. Okay. So that's all that stuff that we're going to do. And somebody might get a chance to log in again, might not. Okay. But the point of this, at various points here, we have branches, right? So we call this a branch statement because the application can go in one way or another. If this is true, if the ID exists in the database, then you go ahead and you check if the password matches it. If the ID doesn't exist, then you get a different kind of fail, right? A fail that isn't associated with an actual ID. So this means 2 things. Number 1, of course, need mechanism for branching conditionally, right? So if something is true, do this. If something is not true, do that conditionally. And number two, need a true-false evaluation. Okay, those are the two things we need. So our Boolean variables are this true-false evaluation, and our conditional statements are the way to direct the program's execution flow according to those conditions. All right, so we're going to move forward. So true-false variables are called Booleans, and they're named after the 19th century mathematician George Boole. If you wondered, that's Boolean, that's a weird name. Well, that's why. So they're Boolean variables. Now, Boolean is the last of the 8 primitives. We've seen them all now. We've seen our 6 numeric ones, we've seen char, and we have seen Boolean. So Boolean holds a true or false value, not convertible to numeric types, and it allows binary branching, either this or that. So standard declaration, Boolean B. The assignment, you can do it same as any other numeric variable. You can do a literal with B equals true, or you can do it as a result of an expression. For example, if I have int x equals 0 and then int y equals 1, I can say Boolean B equals y is greater than x. If y is greater than x, which it is, 1 is greater than 0, then B will be true. But if y were not greater than x, then B would be false. Okay, so you can assign it with a literal, or you can assign it as the result of some expression. All right. Now, the simplest Boolean expression is true or false, but typically, much more often, a Boolean variable results from a set of equality tests or comparisons. Right? That's the way to mostly it happens. You setting up a Boolean to see whether something is true or not. Now, here's an interesting thing. We're going to start with this. We're going to start with equality tests. So, objects have an equals method. If we go and look at the Java equals class, okay, I'll just dig around in the guts of the Java language for a moment. So, Java object class, and we'll find it here in SE7. It has this method. Where's my equals? Oh man, it's not in here in SE7. Oh no, there it is. I was going to say, why am I not finding it? Method detail. Do I not see it? Am I blind? Oh no, there it is. Sorry, my eyes are playing tricks on me a little bit. These damn bifocals. Anyway, yeah, here's our equals method. I was going to say that'd be really weird if it. Anyway, so this is an equals method is used to see whether some object is equal to this one. That means, in general, do they hold the same data? However, here's the issue with equals. Okay. So I'm just going to mention this first. With primitives, you just check if the values are identical. And for equality, that's a double equal symbol. Okay, so you'd say int x equals 3, int y equals 4, Boolean b equals x equals y, b equals false, right? So because x is 3 and y is 4, x equals y, that Boolean test is going to be false because 3 does not equal 4. So we evaluate this, we assign the result to b, thus after this, b would be false. Okay, but with objects, it's murkier. So with objects, you can check for identical values. Typically done with the equals method for that class. And because object has an equals method, every object that inherits from object. Every class that inherits from object will also have an equals method. Well, in Java, all these classes inherit from, all your custom classes inherit from object, so they all do have an equals method. Okay, but the equals method will be custom for that class. So any class can potentially have a different equals method. Now for string, which is the one that we're interested in, for string, equals tests for same text contents. Okay, that's the way string works, and we'll do a demo on that in a second. Now, if you want to test whether two objects are the same object, not just have the same data, okay, you use the double equal symbol, okay? And this is important because if you're checking whether two strings have the matching text, I'll put this in red. If you only want to know whether two strings have the same text, don't use the double equals. Use dot equals. Okay, because otherwise this dot equals will often evaluate to false when you don't want it to. Okay, so let's do an example in Eclipse. We're going to do some fun with strings, fun with Booleans, fun with matching strings. Okay, this isn't going to be that fun, so let's just call it string match. Okay. So string match will have two strings, S and T. So string S and T, boom. Here we'll say string match SM's new string match. And we could do a couple tests. So we'll do one thing, we'll do two static methods. Static void literals and static void non-literals. Okay, so we'll call literals. I guess it's static. I don't even need to make a, let's give it static. Everything's static today. Fine. We don't care. Okay, so let's say S equals, I don't know, give me a word. Gloob. Okay, and T equals gloob. Okay, so clearly they're both literals. So what's going to happen? The IDE creates gloob first, and then when we use the reference to T, T is also going to reference gloob. So they're going to point to the same thing in memory. So if I call literals, okay, I'm going to do this. I'm going to say, I'm just going to put this in here. System.out.println, same string object. I do have to do this. I didn't really want to, but I'm gonna. Plus S equals T. Okay, but if I do this, if I do non-literals, now, I guess I'll do it this way. It's not the best. Not the best way to do this, but we'll go with it. Same text in strings. Let's just do same string text. Leave it at this. I don't care. Okay, boom. S dot equals T. Okay, now it should be obvious since both S and T will be the same object because they're literals, if they're both the same object, then guess what? Their text is going to be the same. So both of these should resolve to true. So let's go ahead and run this. And we see, yeah, okay, same string object, that's great. And same text and strings, yes, also great. Okay, now if we do it with non-literals, we'll do it this. Let's say S equals new string gloob. Okay, and T equals new string gloob. Okay, and then I'm creating new objects. And if I call this non-literals method, I do the same thing here. Well, clearly they're going to have the same text, right? They're both going to read gloob, but they're not going to be the same string object. Okay, so that's this false and true at the bottom. Same string object, no, not correct. Okay. Anyway, so again, you can see if we go back to Paint here, right? If some user enters an ID and password, I convert them to strings, and I check, does the ID exist in the password? And I'm doing if ID double equals whatever's in that list of passwords, it's probably never going to return a match because they're never going to be the same object. Nobody will be able to get into your system. That's a big problem. Okay. So objects have an equals method, returns true if the objects have the same data member values, false otherwise. That's how it works for strings. With a lot of other objects that have an active equals method, that's how it works. But again, they actually have to code it in there because if it just inherits straight from object, it's not really going to do anything. For primitives, the double equals operator resolves to true if the two primitives have the same value, false otherwise. And for objects, the double equals operator resolves to true if the objects are the same object, if they share a reference. Okay. Other key thing, this is one of the most common mistakes in Java, use the double equals for equality tests and only a single equals for assignments. This is one thing that usually dings almost everybody on exam days, is that they use a single equals sign for an equality test. Got to use both. Okay. The other basic Boolean expressions, the operators are pretty much standard. So greater than or equal to, less than or equal to, less than. So here's the way to remember. If an equals symbol is present, it's always the second character, right? So when people are doing their code, they're like, oh, do I do equals or greater than or equals to? I don't remember how, I got to look it up. You don't have to look it up. Just remember the equals always goes second. Okay, even if it's a double equals, still, if there are two characters, the second one's going to be the equals sign. Okay, equals always goes last. And these comparisons only work with numeric types, right? It doesn't make sense to say, is one object greater than or less than another? For example, an object could have two pieces of data, even if they're both numbers, one is greater than the other, maybe the other is less than the other objects. How do you evaluate whether that makes the one object greater or lesser than the other? There's not a method for doing that. You'd have to construct it. I mean, there's not an equality, there's not a comparison test for that. You'd have to set up your own comparison scheme and define it. Okay, so that's it. These basic comparison operators, they're pretty intuitive. I mean, I don't think they deserve a lot of extra explanation. But the and and or is a little tricky. That tends to cause people some troubles, trip people up. So there's and or. The and operator, which is two ampersands, which is generally a shift 7. That's what that is. It's an ampersand. Tests whether two Boolean expressions are both true. For example, if I have true and true, then true and true will resolve to true if they're both true. Okay, but if either one is false, then A and B is false. We'll talk about this in a second. The logical or operator, on the other hand, tests whether either of two Boolean expressions or both is true. So if either one of these or tests is going to be true, then the whole expression is true. So I say A or B, that entire expression resolves to true if either A or B is true. Okay, but if A and B are both false, then A or B is false. I don't have anything in my cup anymore. I drank it. Okay. The not operator, on the other hand, toggles true and false. So not true is going to be false. Not false is going to be true. Just flips it back the other way. Now, interesting thing, by using not, you can always convert an and expression to an or expression and vice versa. So let's get a little detail on that. We're going to do that. Let's see what's here. Yeah. Okay. So imagine you have been arrested by the police and you are accused of a terrible, terrible crime. And maybe you did it, maybe you didn't, I don't know. Probably didn't, but who knows? These are strange times. Okay. We are going to set up a Boolean for this, a little 2x2 matrix. 2x2 matrix of criminal justice system outcomes. Okay, so very good. Now our first thing, guilty. Did you do it? Well, no, or yes. Okay, now we're going to assume that the system works the way it's intended to, and that if you didn't do it, you go free. Okay, so that's good. So anytime you bump that, so go free, and likewise down here, go free. Now the other option, your lawyer. Oops, lawyer. Good. Let's say skilled or unskilled. Okay. Now, if you have a skilled lawyer, even if you're guilty, well, you're going to go free. That's what we're going to say. All right. The system's not perfect. On the other hand, if you have an unskilled lawyer and you're guilty, we will say, you know, convicted. Okay, so that's what's going to happen. That's our assumption for this model. Okay, everybody got this? Let's convert this to a Boolean, a set of Boolean expressions. I'm going to shrink this down. There we go. That scaled pretty nicely. So first thing, how would we say this? How would we say this to say if you are, under what circumstances would you be convicted? Well, convicted if guilty and unskilled. Okay? That's the intersection of those two. If you both are guilty and your lawyer is unskilled, then you get convicted, right? Otherwise, go free. So this is with an and statement. And the and statement, because there's, you know, one of these things that we're interested in, it's easier to express this as an and statement. But the opposite of this, we can say the otherwise would be this. The otherwise is simply not guilty and unskilled. Now we know under what circumstances do you go free? So we can express that with an or statement. Go free if skilled lawyer or not guilty, right? If either one of those is true, right? Skilled lawyer, boom, you're guaranteed to go free in this scenario. Not guilty, boom, you're guaranteed to go free. Okay, so we know that these two must be equivalent because they're both the cases where you go free. So skilled or not guilty in this setup is the equivalent of not guilty or and unskilled, right? Likewise, if we wanted to copy this, do the same thing, right? I'll put an exclam here. Good. Meant to do that. Oh, this is a pain. I guess I'm just going to do it this way. Boom. Okay, so I know likewise these two must be the same. Okay, so I add them down here. Otherwise convicted. So it is always possible to convert an and statement to an or statement and vice versa. That's the takeaway from this. Okay, but usually one of them, it's going to be pretty clear. There's one of them that's easier to work with. In this case, if I ask you, how are you going to get convicted? Well, you can kind of look at the chart. I'll say, oh, it's the intersection of these two. So if this is true and this is true, then you're convicted. If I ask you about the or, you're going to say, oh, it's these, right? So if it's either this line or this line. So if it's either skilled lawyer or not guilty, then you go free. So depending on what you're looking for, one of these ways of expressing it will be more natural, but there's always, you can always structure it the other way. So an or is always going to be equivalent to some and statement and vice versa. Okay, and there we have that little right up there. Okay, one more thing. We're going to cover short circuit evaluation. Then we'll actually do some order of operation stuff. We'll come back to that on Wednesday. So short circuit evaluation. This is a neat little thing that Java uses. It streamlines evaluating ands and ors. So basically, imagine if you have some case where suppose you have a long expression, right? Suppose you say, give access to user if, we're going to say one, user has locally stored access credentials. Right, basically a cookie or its equivalent, okay? Something session key, a cookie with an active session key. So the user has some session credentials there on his machine. Or user can be verified through outside actions, whatever. Now, the key things, this test, very quick, no network required. Okay, whereas this one, right, so you don't have any network communicate, no network action required. More what I was getting with that. This one, on the other hand, not so quick, may require user involvement, user actions. So the user's got to do something. So if you can, of course, this is the thing you want to rely on, but this is the thing that you fall back on. So what you might do in your code, you would write something like this. If local credentials, okay, so let's, we're gonna do a Boolean for that. Boolean local credentials equals ... whatever those credentials are. And then if necessary, we have some other Boolean remote credentials. Okay. Dot. We're going to initially say that's something. Okay. Actually, we wouldn't even do that. We could do this. Let's say we have two methods. We'll do it this way. We have two methods that we can call. It has local credentials, which returns a Boolean, or has remote credentials, right? Which also returns a Boolean. And that, you know, give access. Okay. So this method, two methods that have Booleans, return Booleans. Both methods return Booleans. Okay. Now, if we're doing some kind of check like this, we want to do this one, and we hopefully don't have to do this one. Well, this is back to our short circuit evaluation. I can test this one. If this is true, Java doesn't need to evaluate the second method call. Okay? Because true, right? Because this entire expression will resolve to true. That means don't have to spend time waiting. So what's going to happen is, oh, if you have the local credentials, great. You're going to skip over this. You're not going to do this remote credentials method call. You're not going to wait for the results to come back. You're just going to go forward. So this kind of short circuit evaluation can make your applications run a lot faster, because if you have a quick answer that is sufficient, it's going to try to get that first. Okay, similarly, I'll add short circuit evaluation works the same way for and statements. If either, or if any of the and statements are false, any of the statements in the and are false, then the entire and is false. Okay, and we could do that with something like, let's say, different types of locking out of the account, right? So I might say, I have a couple ones. So if, you know, user attempts failed, is greater than 4, right? On the 5th attempt, you get locked out. And, oh no, so that is user attempts is less than 5, and user, what, in, shit, this isn't working well. Well, I don't have a good example at the moment. I'm just going to leave it as is, okay? But the same thing, if I have two things in the and that are going to be false, then the entire and is going to be false. I was thinking of some reason why you'd get locked out of your account. And, right, the first time you find one that's false, then, yeah, but anyway, wasn't coming up with a good example off the top of my head, so that's fine. And we're running low on time anyway. So short circuit evaluation, if you have an and statement, it's if the first one is false, then the entire and is going to be false. It's not going to evaluate the subsequent ones. Likewise with an or, if the first statement, the first Boolean in there is true, then the entire or statement is going to be true. It's not going to evaluate the rest of them. And again, in practice, you can structure your logical tests to be less computationally burdensome or to go faster because they use local data instead of remote data. So that's short circuit evaluation. A good example, actually, we used to do this with math, right? So something like this. If, suppose I have two numbers, int x and z, right? And I might test something like if x is less than 0, or say x is greater than 0, or z divided by x equals something, right? Or I do even do and if x equals 0 and x does not equal 0. So this is something I might do. I say, okay, if x is 0, then I know this math is going to be screwed up and I can't test it, right? Or if z divided by x equals a particular value. Well, if x is 0, then z divided by x is going to be kind of meaningless. It's not going to make your program crash in Java, but you'll get some weird number, typically infinity. In some cases, you might get not a number, NaN. So these are some things that you can worry about. So this one, again, if x equals 0, if that turns out to be true, right, if x doesn't equal 0, then I can evaluate the z divided by x. If x does equal 0, right, if this is false, then I'm going to skip over the and part of it. All right, so that's a case where you might use that. Anyway, all right, this is enough. This is a good break point, so I'm going to stop the recording.